So in this periodic table, we can see that the numbers on the top of each element are the atomic numbers of the elements, and the atomic number tells us how many protons and electrons there are in one atom of the element. So for example, if we have a look at potassium here, it has an atomic number of 19. Okay, so that means that there are 19 protons in an atom of potassium, which also means there are 19 electrons, because in every atom there are the same number of protons and the same number of electrons. So what we want to know about is the arrangement of electrons in an atom, and they whiz around the nucleus in different energy levels. We've learned in class that those energy levels are called shells, and the first shell can hold only 2 electrons, and every shell after that can hold up to 8 electrons. Now, when we look at the atomic number for potassium, we can see that there's 19 electrons there. So in the first shell, we're going to have 2 electrons. In the second shell, we're going to be able to fill it and put 8 in it. In the third shell, we can also put 8 in that as well. So we look at what we have so far. We've 2 in the first, 8 in the second, and 8 in the third. So that adds up to 18 electrons altogether. So we're going to have to move on to the final shell and put 1 in it. So by writing the numbers down of what electrons go in each shell, it'll make it easier when you go to draw the Bohr diagram. So we'll start with the nucleus of potassium. Now, I've said that there are 2 electrons in the first shell. So I can just draw them in on either side of the first shell. In the second shell, there are 8 electrons. So I have to draw another shell around here. And then I just start filling in 8 electrons in that shell. So you can see on the third shell, I've got 8 electrons. So going back to my atomic number of 19, I have put 2 electrons in the first shell. So I'm going to tick that. I've put 8 electrons in the second shell. I've put 8 electrons in the third shell, and I'm still left with 1 over. So I'll just place the last one anywhere on the fourth shell. And there's my Bohr diagram for potassium done. So what we know from this is that potassium is very unstable because it has 1 electron in its outer shell, and it's not happy with that. It's very unstable and it wants to get rid of that negative electron on the outer shell. After we looked at Bohr diagrams, we went on to look at ions. So if potassium was to become stable, it wants to get rid of that electron that's on the outer shell. So what we were saying in class is that it wants to get rid of that negativity. So we want to give that electron to another element. All right. So if we're losing that electrons are negative, we will end up becoming a little bit more positive. So potassium will end up being a positive ion when it reacts with another element, and it gives that negative electron to another element. We also know that potassium is in group 1, and this is group 1 here, and they're the alkali metals. So every one of those elements that are in group 1, we're not including hydrogen. So every other element that is in group 1, they have 1 electron in their outer shell. So they might have less shells or more shells outside the nucleus, but they will all have only 1 electron in that outer shell. So that's why we say that group 1, they are quite unstable. Okay, they're dying to get rid of that electron. And you can see that those elements are just going to get more reactive as they move down that group, because they're going to have more and more shells outside the nucleus. So the more shells that go around the nucleus, the further away that electron is, so the more reactive it is going to be. And we can remember from the experiment we did on the reaction of alkalis in water that potassium was way more reactive than sodium and lithium. So sodium was more reactive than lithium, and potassium was more reactive than sodium because it's got more shells around the nucleus, and that 1 electron that's left on its own is so far away from that nucleus.